Hello everyone, welcome to 5.3 day 1. Today we're going to be solving trig functions, something that we've kind of done in the past. I think you should get it pretty easily. You'll also like this because it doesn't really involve trig identities at all. In fact, we're only going to use probably one throughout the notes today. So let's go ahead and jump on into one. So we're trying to solve this for x. So just like solving an equation, we would want to add the 1 over. Then you're saying, okay, divide by 2. And then to undo this cosine, we want to do inverse cosine. So you're going to ask yourself, what has a cosine value of a half? And hopefully you remember your unit circle. That's something that you can't really forget. So thinking about the unit circle, I want it to be a half. And cosine is our x values. It goes cosine, like this is our cosine, this is our sine value. So I'm thinking, what has a cosine value of a half? Well, a half would be about right there. So cosine being a half, that would be pi over 3. And then we also have this value down here. So that's pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. So this has two answers to it, pi over 3 and 5 pi over 3. And if you remember anything about the unit circle, there's a lot more coterminal answers. So we have way more than 2. For today, though, we want just the answers from 0 to 2 pi, just one revolution on the unit circle. And then that would be it. That's our answers for that. Okay, next one. Go ahead and take a minute, pause the video, write this down. All right, so we're wanting to get x by itself. First thing I see is move the 2 over. Then we want to divide the 3 over. And then here we want to do inverse secant. Well, that's probably not, you probably don't have the secant values memorized. If you do, then go ahead and write down your answer. For me, I don't have that memorized, but what I do know is I know that secant is really the same thing as cosine, it's just cosine flipped. So what I'm thinking in my head is, well, the cosine value would just be this flipped. All right, well, that's not something that I know either, so I need to actually rationalize this a little bit. So I'm going to multiply the top and bottom by that radical 3. And then 3 over 6 that can reduce, so that would be negative radical 3 over 2. So I'm asking myself, what has a cosine value of negative radical 3 over 2? Thinking of that unit circle again. Negative, like it's a cosine, so cosine is our x values. Negative radical 3 over 2, that would be like there, like it's a half radical 2 over 2, radical 3 over 2. So I'm thinking that value and that value. Well, that's pi over 6 is what it looks like. That's 6 pi over 6, so that's got to be 5 pi over 6. And then if that's 6 pi over 6, that's 7 pi over 6. So that would be our two answers for that one. All right, next one. So this looks kind of tough. You might be thinking, I'll go ahead and distribute that, and that would be one way you could do it. I want to do this a little bit of a different way, though. It's something that we did probably back in Algebra 2 is when you saw it, most likely. It's called the zero product property. If you look at this, it kind of looks like it's in a factored form. That's basically where the zero product property gets used the most, is when you're solving by factoring. If you remember, all you do is you just set each factor equal to 0. And then just solve each of those. So this one, it's already by itself. We just have to get rid of the cosine. So we're asking ourselves, what has a cosine value of 0? Think of our unit circle again. The cosine value, that's x. So cosine is 0 at pi over 2, and cosine is 0 at 3 pi over 2. For this one, we would have to subtract the 1 over. And then we ask ourselves, what has a cosine value of -1? Well, cosine is our x value. -1 would be right here. So that would mean it would just be pi. All right. Before we go on to the next example, got a little joke for you. What did the acorn say a few years after it was planted by a mathematician? Think about it for a second. And the answer is G, I'm a tree. And that's our watch code for today. Geometry. That is our watch code. So go ahead and email that to me. Make sure you get all the credit for watching the video. Next example. Alright, so this one looks kind of tough. First thing that I'm going to do is move that cosine over. The way that we would move the cosine over is we would divide it. And you'll kind of see why I wanted to move the cosine here in a little bit. For right now, just trust me. That's what we want to do. Alright, and earlier I said that we were going to use one trig identity. This is a trig identity that we're using. Sine over cosine. Well, we know sine over cosine is tangent. Since they were both squared, it's tangent squared. If it didn't have the squared, then we would just ask ourselves what has a tangent value of 1/3. That's not when it's on the unit circle. You'd have to draw your triangle and figure it out that way. For this one, we're going to have to take the square root first before we ask ourselves what has a tangent value of something. Okay, when we solve by taking a square root, something has to go in front of here, and that is a plus or minus. Hopefully you remembered about that. Taking the square root of a fraction, you just take the square root on top and the square root on the bottom. So really what this is saying is the square root of 1, which is 1. Square root of 3 is just the square root of 3. Now the square root of 3 being on the bottom, we have to rationalize that. So multiply the top and bottom by a radical 3. That would give you radical 3 over 3. Okay, so again, this is probably not, you probably didn't memorize the tangent values for all of your unit circle. So what you would have to do is kind of think, well, I know it's not pi over 4, because I know the pi over 4s, those are all going to be 1 for the tangent value. So it's either pi over 6 or pi over 3. So I'm thinking, well, if it's pi over 6, sine over cosine. Sine of pi over 6 is a half. Cosine of pi over 6 is radical 3 over 2. If I divide those, multiply by the reciprocal, or do your keep, switch, flip, you would get 1 over radical 3. And when you rationalize that, you get radical 3 over 3. So that's our winner. So it looks like it's going to be the pi over 6. Now it's positive and negative. So the tangent value being positive, that would go with pi over 6 and 7 pi over 6. For this being a negative value, the tangent would be negative if it was 5 pi over 6 and also 11 pi over 6. And then that would be our answer. This one had 4 answers to it because of the plus or minus part. All right, last thing that we need to talk about is solving these with a graphing calculator. So this one, you could kind of do the same thing that we did before. You could move the, actually, no, you could not. This would be something that you could not solve by hand. Like we couldn't, you could add the cosine over and move the 3 over, but then you would kind of be stuck. You couldn't really solve it. So you would have to use a graphing calculator. If you remember how to use your graphing calculator to solve an equation, all you do is you just graph this side as one equation, graph this as one equation, and then just see where they cross at. When you do this, you want to make sure that you're in radian mode, and our answers are going to be on the interval 0 to 2 pi. I put a closed bracket on it because it can actually include 0 and 2 pi. So graph the left side, graph the right side. We want to see where these cross at. Since our interval is 0 to 2 pi, it might be a good idea to change our window around. So if you get a window for the x values, it's 0 to 2 pi, so 2 pi. And then that would make it where you're only seeing the values that you actually want. That's one rotation on the unit circle. So it looks like we're trying to find that value and that value. Make sure that you're in radian mode. If you're in degree mode, you're going to get the wrong answer. So you want to see where they cross at. First and second curve, just hit enter and enter because we only have 2 curves to choose from. And then guess. So that's going to be our first one, 2.820. Alright, then go through, do the same thing again, go down to intersect. First and second curve, just hit enter twice. We want to go all the way over here. And there we go, 5.961 would be our second answer. And that's really how you would do it with a graphing calculator, pretty easy. That's it for today. Make sure you email me the watch code. Until next time.